So we're going to start with the ellipses with changing this to standard form. So that means we need to get it into that basic form of x minus h squared over a squared plus y minus k squared over b squared equals 1. I like these, but I do them so much through the years I should make little ditties out of it and have fun with it. We want that format. What we don't know is whether it should be x minus h over the a squared or y minus k over the a squared. We'll figure it out as we do it. Because when we get to the end, whichever one is larger underneath here automatically becomes the a squared. And then we'll move it if we need to. So your first thing to do is put the x's together. Leave space for the c you're going to put in. Actually, we won't yet because we've got to take a divisor out. Plus 25y squared plus 100y. And move that 36 to the other side. You remember from the past how to take the coefficient, the common number out from both of these. So those are the first things that you have to remember about if you haven't looked at these since last year, is that you've got to get it so the parentheses, the inside part, that the x and the y, the x squared and y squared do not have a coefficient. Because you need that, you need it to be that in that format in order to figure out what the c is here that you want. So when you do c over 2, that the c is equal to the b over 2 squared. So in order to use that, you have to be working in the inside part where that 4 has already been taken out from the negative 24. So we use a negative 6. So negative 6 over 2 is negative 3, and when you square that, you get a 9. So that means we're going to add 9 here in just a moment. Okay? So I'm going to put a 9 in here. Over here, I'm going to do 4 over 2 squared. That's 2. 2 squared is 4. So I'm going to add 4 in there. So I'm going to have, and if I have a 9 here, 4, well, if this is x squared minus 6x plus 9, that means it's now a perfect perfect square. Okay? So I can do x minus 3 and square it. Remember, you take the b and take half of it. If you multiply this out, you'll get x squared minus 6x plus 9. Over here, same thing. Y squared, well, if I have it a 4 here, that means this is y plus 2 squared. So I forgot to put that squared there. I'm going to put it on the outside. Now, I added 9 here, so that means I have to add 9 here. I added 4 here, so that means I needed to add 4 here. So this is where one of the mistakes people sometimes make. I sort of have purposely made that here, although it's very easy to fix. When I added 9 here, I have to add 9 on the other side. But that's not a 9. Remember that that's really 36. Because of the 4 out here multiplying to it, what I did when I put 9 here was I put in 36 on this side. So I need to do like, 9 times 4. So if that's a 9, I can just put times 4. And when I put this 4 here, it's really 4 times 25, so I'll do 25. So I actually have 9 minus 36, plus 36, and plus 100. So that means those will cancel out anyway. Let's clean it up. And at this point, all you have to do is make sure you get a 1 here. Divide by 100 on both of them, and you get, if I divide this one by 100, 4 goes in 125 times. Do it here, I'm going to get a 4. And I now have what I want, standard form. It turns out that the larger number on the bottom is under the x, so we'll keep it that way. If this had been 25 and that was 4, we would then reverse it and put y plus 2 squared over 25 first. Okay? But now we know that a is 5, the b is 2. So we could set up, we know the center is positive 3 and negative 2, so we could put the center, we could do a and b both ways. We could draw the ellipse if we wanted to. Okay? But this is something I want you to be able to do. So please make sure you're ready to change the equation around. And also, if we get to it, we'll be doing one with hyperbola, because that's the same thing I want you to do with hyperbola. The only difference is that negative. Okay. Now, the next type of equation I want to look at here for the ellipse, and actually, come back for a moment, just to do a little bit of graphing, because you do have to, you have to graph one for the addendum. Just do a little graph. +3 and -2 would be about here. So I'm going to call that +3 and that -2. The A is 5, so I know I'm going this way because I'm parallel to the x-axis. So I'm going to go over 5, which is say about here, and over 5. The other one, the B, is 2, so I'm only going up a little bit. That was -3 and 2, so I'm going here, and I'm going down here, so on an actual graph with the numbers, that would be a lot better. But that's approximately where it's going to be. So that's all you have to do. If I wanted to find the focus points, let's do that as an exercise. The focus points are inside it. And remember, because they're inside, now, this is a distance of C here. Well, this part was a distance of A. You can't do A squared plus B squared is C squared when the C is smaller than the A. There, now that looks more, still doesn't look enough like a C. There, okay, let's hope that counts. So, if the C is smaller than the A squared minus plus B squared is not possible, but minus B squared is, because then that allows the A to be larger. So if I wanted to know what this distance was in order to figure out where the C was, remember that you'll do that C squared is equal to A squared minus B squared. And we have A squared and B squared. So C squared is 25 minus 4. C squared is 21. Square root of that is going to be about 4.5, maybe 4.6, just because 21 is between 16 and 25. Approximately 4.6. So I would take the center and I would move 4.6 and move 4.6, and that would give me the coordinates for the focus points, if I needed to find you. Just to let you know. Okay. So the next thing to look at, call that part 1. I think graphing it is sort of like a part 2 of this. Okay. Not hard to do when you have it in the right form. And then part 3, part 1. Write the equation of the ellipse with endpoints of the axes -6, 0, 0, 0, -3, -5, -3, 5. Okay, that's enough information for us to get what we need. Remember, since we're going to be getting this form, you only need 3 things to make the equation. You need the center, which gives you the h and the k. I guess that's 2 things, but really the center I'm thinking of is 1 thing. And you know what the a is and you know what the b is. If you graph that, you'll get all 3 really easily. You don't have to graph it. Once again, you don't have to do something like that. But making a sketch or a drawing or graphing something is one of the techniques you can use to solve problems, and it works perfectly for these kinds of things. So I'm going to figure out, I'm going from -6 to up and down 5. So let's do a basic graph here. So go 1, 2, 3, about 3, 4, 5, -5. So that's -6. Then go 1, 2, 3, 4, 5. 1, 2, 3, 4, -5, because I can see that I'm going to use here. +5. 1, 2, 3, 4. Don't think I'm going out that far anyway. So -6, x and y and 0 is right here. 0, 0 is here. -3 and -5 is here. And -3 and +5 is here. If you don't graph it, it's sort of hard to figure out which one is going to be the major axis and which one's going to be the minor axis. If you graph it, now it becomes really easy to see what our distances are here. Okay. So I can see I have a distance of 3 here, and 3 here, and I have a distance here of 5 and a distance here of 5. The larger one is A, so A is equal to 5, and B is equal to 3. So now we know A squared and B squared. So we also can figure out the center, because it looks like the center is here at -3 for the x and 0 for the y. So now we know the center. So we can put the center in there, and we can put the A in here, so that would be 25, and this would be 9. But we have a little problem, and that's that the major axis is going up and down. It's parallel to the y squared. So that means that this and this need to switch. So what I'm going to do is y minus k squared over a squared plus x minus h squared over b squared is equal to 1. So I'm going to reverse those because I can now see that the major axis is vertical. If it's vertical, that means the y-axis, or the y, because of the y-axis, that's the one that has to come over the a squared. So I know that the k is 0, so y minus 0, so it's just y squared. And the a is 5, so it's 25. Plus, here it's x minus a -3, which makes it x plus 3 squared. And the b is 3, so squaring that is 9. And we've now made the equation because we had enough information to figure out where the center was, to figure out whether it's vertical or horizontal, because that one's larger, and to use those numbers as A and B. So if you're given that much information, you can do this. Let's do another problem where there's other different information that I'm dealing with. I have almost enough room on the bottom of that one, but I'm not sure enough to do it, so I'm going to do this one. I'll call this part 4. Write the equation. I'm tired of writing of the ellipse, so just understood that it's of the ellipse. The equation when the focus points are 6, 3, and -6, 3. And the, okay, I don't want to call it vertices, and the major axis endpoints are 7, 3 and -7, 3. Okay. Once again, my method's just let me do a little graph. Okay, so it looks like I'm doing positives. The y is going to be 3, so I'll go like this. So 1, 2, 3. 1, 2, 3, 4, 5. Whoops, I pushed myself out to 6 and 7 now. 1, 2, make this a little too big. 3, 4, 5, 6, 7. Okay. So I'm going to go to -6 and 3 and 6 and 3. -7, 3, and 7 and 3. So using those numbers, you can sometimes still figure out what you're doing without doing a little graph, but I think it helps to do this. Because I now know if I go right in between these, the center is right here, right in between either lines, but that tells me what my h and k are. The center will be 0 for the x and +3 for the y. So I now know my center. Since the major axis is going this way, that means I do know right now that the x squared one is going to be over the a squared. plus, well, actually, I know that's going to be x minus 0. This is going to be y minus 3 squared over b squared is equal to 1. So we know these. When I do the next working it out, I will take away the 0 because I don't need that there. But I need the minus 3 for the y, so it's 0 and 3. I now need to know a and b. Well, a is easy because remember that major point endpoints are also the vertices. I avoided saying that while I was doing it because I wanted to focus on the fact that you're looking at a major axis. Although I could have done it with vertices and said, yep, got the major axis. So the distance over here from the center to those endpoints is a distance of 7. So that means this one's 49. Okay. So the only actual really hard part on this is now figuring out what the b is so you can do b squared. Okay? And for that, we have enough information because of where the distance to the focus points are to figure out what c is. So this c is for the center. This c is the amount, the distance from here out to the focus point. And we already know that that's going to be going 6 and going 6. So that means c is equal to 6. So for this equation, we need to know what the b is. This is an ellipse, so that means we have to do the a squared minus b squared is equal to c squared. Okay. And that's because the distance c is less than the distance a. But we can put a 49 in here, and we can put a 36 in here. So negative b squared is equal to 36 minus 49, which is what, 13? Negative 13? I think it is, it's negative 13, right? Okay, but then the negatives cancel out. So b is the square root of 13. Plus or minus, but we'll only use the positive for here. Oh, but wait a minute, I didn't even need to do that part. All I needed was b squared. All we need is 13. So x over 49 plus y minus 3 squared over 13 equals 1, and we have our equation. I went too far? That's okay, I just remembered to come back to it. So now what you see here is if you're given some information, it can be different from the information here, because in this one you were given the b, by what you had here, you had enough to get the b. You never had to figure out the c for that one. Here you needed to figure out the b, so you had to use what they gave you from for the c. And then, where's my other problem that I put here? The ellipses. Oh, there it is. Okay, so part 1 and part 2. So changing to the standard form and knowing how to graph it, writing equations based on the information you're given, that's what you need to do for the ellipse.